Chapter 1. Chemistry is the study of matter. You could say that chemistry is the science that studies all the stuff in the entire world. A more scientific term for stuff is matter. So chemistry is the study of matter. Matter is all the physical things in the universe, all the stars in the galaxies, the sun and the planets in our solar system, the earth and everything on it are matter. All human-made objects, all organisms, all gases in the atmosphere, and anything else that has mass and takes up space, including you, are examples of matter. Chemistry is special because it looks at the matter all the way down to the smallest parts, the atoms and molecules that matter is made of. To give you an idea about how small atoms and molecules are, use a metric ruler and look at the length of 1 millimeter. It's about the size of a dash, like this one, right here. Try drawing a tiny line or a dot that is about 1/10 as long as the dash. It might be about the size of a period, like the one at the end of the sentence. A hydrogen atom is about 1/10,000,000th of the size of the period. So it would take 10 million hydrogen atoms lined up next to each other to go from one side of a period to the other. Right. Let's get down to this next part here too. Studying chemistry can help make sense of many of the different things you see and do every day. What you eat and drink, the weather outside, the soap and water you wash with, the clothes you wear are all a result of chemistry. The sports equipment you use, the materials in your house is made of, and the way you get to school, and the electronic equipment you use are all a result of the interactions of atoms and molecules. Having a better idea what atoms and molecules are and how they interact can help you better understand the world around you. Matter is made of atoms and molecules. We've already used the term atom and molecule a couple times. You'll learn a lot more about atoms and molecules in later chapters. For now, let's just say that atoms and molecules are extremely tiny particles that make up all the matter on Earth. An atom is the basic building block of all matter. A molecule is made of 2 or more atoms, connected or bonded together. Even though atoms and molecules are not the same, the model we are using in Chapter 1 shows both atoms and molecules as little circles or spheres. This model makes it easier to show some of the basic characteristics of the different states of matter on Earth. Matter, solid, liquid, gas. On Earth, matter is either found as a solid, liquid, or gas. A particular solid, liquid, or gas might be made of individual atoms or molecules. Here's a simplified model of 3 different substances. One's a solid, another's a liquid, and another's a gas. You can see how the atoms and molecules inside of there are really tightly packed together, or a little bit loose so they can flow and slide past each other, and the gas have lots of room up there. And here's where it explains that too. But as you look at these pictures, think about the 2 big ideas, which were always true when talking about matter. Matter, solid, liquid, gas, is made of tiny particles called atoms and molecules. The second one, atoms or molecules that make up matter are always in motion. These first 2 ideas make up a very important theory called the kinetic molecular theory of matter, which just means that atoms are always in motion. Another big idea is that the atoms or molecules that make up a solid, liquid, or gas are attracted to one another. In a solid, the atoms are very attracted to one another. Because of this strong attraction, the atoms are held tightly together. These attractions are strong enough that the atoms can only vibrate where they are. They cannot move past one another. This is why a solid keeps its shape. And here's a diagram of a solid. You can see that those 2 little lines out there are just kind of showing those vibrations of that moving in its place there. In a liquid, the molecules are also in motion. The attractions between these molecules and liquids are strong enough to keep the molecules close together, but not in a fixed position, like a solid would be. Although the molecules stay very near one another, the attractions allow the molecules of a liquid to move past one another, or flow from one spot to the other. That's why a liquid can easily change its shape. Lastly, in a gas, the molecules are also moving. The attractions between the molecules of a gas are too weak to bring the molecules together. This is why gas molecules barely interact with one another and are very far apart compared to the molecules of liquids and solids. A gas will spread out evenly to fill any container. When looking at the different states of matter, it's kind of like a competition between the attractions the molecules have for each other compared to the motion of their molecules. The attractions tend to keep the atoms or molecules together, while the motion tends to make the atoms come apart. Here, looking at this chart here too, talking about, and these are things you guys will need to know in this unit and have to be able to fill these blanks in at some point too. So it talks about how in this column down here, solids, atoms are very attracted to each other. They vibrate in place, but they don't move past each other. They're kind of stuck in one spot. In volume, so solids have a definite volume and a definite shape. Liquids, the atoms and molecules are attracted to another. They vibrate, but are able to move past one another, and sometimes we'll refer to that as able to flow past one another. And liquids have a definite volume, but not a definite shape. They said earlier it takes the shape of its container. And gases, they're barely attracted to one another. They vibrate and they move freely past each other. Does not have a definite volume or a definite shape. All right. So heating and cooling a liquid can affect how far apart or close together the molecules are. You can see these diagrams of cold water, and these are the atoms and molecules inside of those. This is room temperature, and here's in hot water. One example is the red alcohol inside the thin tube of a thermometer. When the thermometer is heated, the molecules of alcohol move faster. This faster motion competes with the attraction between the molecules, which causes them to spread out a little. They have nowhere else to go, so they move up the tube. When the thermometer is cooled, the molecules of alcohol slow down, and the attractions bring the molecules close together. This attraction between the molecules brings the alcohol down in the tube. Just wanted to show this one too. You can see how in the cold water there's just these little motion lines on the outside. See how there's just one line here, and then as it warms up to room temperature there's two lines showing that the motion of those particles is moving faster, and then obviously with hot water there's three lines to really show that too. So all right. And that is where we're going to stop here. And the others will be some demonstrations that we'll use to help fill in our brochures here too. So